Hey, didn't see you there. PJ Allen here. Today I'm going to teach you about the physics of golf.
Hi, Vinny Condo here. I'm here to tell you what not to do in golf.
First, I'm going to teach you how a wedge works. Now we'll move on to an iron. This is a hybrid, a combination between an iron, which you just saw, and a wood, which we'll get to later.
Ironwood. This is wood.
And this is a driver.
Tee at 14.
Fairway.
Monster tee shots all have one thing in common: huge clubhead speed. To examine the keys to creating velocity, we brought two of golf's biggest hitters into the ESPN Sports Science Lab: Bubba Watson and Dustin Johnson. How do you hit the ball a country mile?
Big part of it is flexibility. You know, very flexible. That helps.
Flexibility is necessary to create maximum torque. The force generated when a golfer twists and unwinds around his spine. Dustin's hips turn 41 degrees, while his shoulders turn 152 degrees, for an angular displacement between his shoulders and hips of 111 degrees. By some estimates, that's 50% more than the average tour player. And by firing his hips forward to initiate the downswing, he actually increases the angle. This enables him to accelerate the club head up to over 120 miles an hour, generating forces that drive the ball, on average, over 311 yards. Bubba Watson, on the other hand, gets his length off the tee using the length of his swing.
For me, it's using the arc. The bigger the arc, the higher the club head speed.
The average golfer's backswing stops with the driver roughly parallel to the ground. Bubba swings 39 degrees past parallel. And from there, the club head creates an arc roughly 22 feet long. And like Dustin, he accelerates the club head to speeds over 120 miles an hour, roughly 25% faster than the average amateur player. The ball is in contact with the club head for roughly half a millisecond, imparting peak forces of up to 3,000 pounds. The result is a ball speed over 180 miles an hour. And Bubba's drives lead the PGA Tour, averaging over 313 yards. Big drives at the Masters help, but they don't always need to be straight. Last year, one of the field's longest drivers was also one of the least accurate, hitting only about 60% of the fairways. And that was the winner, Phil Mickelson. For ESPN Sports Science, I'm John Brinkus.
Steve Quintavala is an engineer in the Equipment Standards Department at the United States Golf Association. He says dimples are crucial to a golf ball's flight.
A golf ball has dimples to reduce wind resistance or aerodynamic drag. When you reduce it, you can make golf balls go a lot farther.
Early golfers using smooth golf balls realized that the more they used a ball, the farther it would go.
The reason for that, they quickly discovered, was that the surface gets scuffed and knocked about. They started figuring out, hey, we're going to put round impressions, round dimples in.
As a golf ball flies through the air, the airflow interacts with the surface of the ball and can greatly affect the amount of drag.
The wind is meeting the surface here and pushing against it and then wrapping around.
If the golf ball were smooth, the air flowing closest to the surface of the ball would follow the flow of air around it, creating a detached airflow behind the ball.
As air flows around the smooth golf ball, it becomes detached. The air that's closest to the surface doesn't want to stick to the surface, it wants to stick to the fast-moving flow.
The detached flow causes a wake to form behind the ball, which creates a low-pressure zone. This zone is what causes drag.
And that's almost like a vacuum. That's sucking the ball back and slowing it down in the face of the wind.
Adding dimples to the ball changes how the air flows over it. As the air travels over one of the dimples, a tiny pocket of turbulence or air disturbance is created on the surface.
It tries to go in and then has a region where it's actually detached, but then by the time you get to the next dimple in the ball, it reattaches itself. And in the process of that detachment, reattachment, that's what creates the turbulence.
Instead of impeding the flight of the ball, these tiny pockets of turbulence allow the closer layer of air to travel tighter around it.
Because these dimples have caused some low-level turbulence, it's mixing the high-speed air from out here and bringing it close to the ball so that that flow can remain attached to the ball.
A more attached airflow creates a smaller wake, and thus a smaller low-pressure zone, which means less drag. Even this slight change can make a big difference.
A golf ball with dimples will go almost twice as far as a golf ball without.
The dimples also aid the flight of the ball by influencing the lift as the ball spins through the air. Lift force is a result of a concept in aerodynamics known as Bernoulli's principle. The principle states that as the speed of the airflow is increased, the pressure of the airflow on the ball is decreased, creating lift. The lift is pronounced due to the dimples on the ball, which measure only 0.15 of a millimeter.